Today we are going to discuss on new unit 9, hydrogen. As we all know, hydrogen is the first element in the periodic table. Okay, hydrogen is the simplest element also. It has one proton and one electron with atomic number 1. So let's go to the introduction. Okay, so hydrogen is the most abundant element in the universe. Okay, universe, and third most abundant third most abundant on earth. Okay, so in universe, okay, in space, okay, hydrogen is abundant. Okay, those stars. Okay, if you go study about the stars, nebula and all, okay, black hole and all, okay, you will come across hydrogen. Okay, but we won't go further into those details. Okay, so this will be, okay, the introduction. Okay, so hydrogen has one proton and one electron, okay, with atomic number 1 and electronic configuration 1s1. So hydrogen, we all know, it is a gas. Okay, a very light gas. Okay, lighter than air. Okay, so hydrogen in elemental form exists as exists in diatomic form. Okay, H2 form. Okay, it does not exist freely like H. Okay, but H2 form. Now let's see the resemblance of hydrogen with alkali metal. Okay, so electronic configuration is given. Okay, let me write in short: electronic configuration EC. Okay, 1s1. Okay, so alkali, they also have electronic configuration. Okay, let's say lithium, electronic configuration helium 2s1, sodium Ne 3s1. So for alkali also, the last electron enter s orbital. Okay, even for hydrogen, the last electron enter s orbital. Okay, so this represent the electron. Okay, so that means one electron. Okay, so this alkali metal can, suppose lithium can lose one electron. Okay, lithium can lose one electron and become Li plus. Okay, same way sodium can lose one electron and become Na plus. Okay, so this plus count because electron is removed, one electron is removed. Okay, in the same way hydrogen can become H plus, okay, by removal of one electron. Okay, so they become uni-positive, okay, ions such as Li plus Na plus. Okay, uni-positive ion Na plus Li plus. So this is the similarity of hydrogen with the alkali metals, okay, or the first group element. So like alkali metals, okay, the hydrogen also form halides. Okay, form halides, sulfides, and oxides. Okay, like alkali metal, the hydrogen also from halides. Okay, let's see. HCl for hydrogen, NaCl, KCl, okay, etc. Sulfides, H2S, okay, Li2S, okay, oxides, H2O water, okay, Li2O, okay, Na2O, okay. These are the oxides, okay. Reaction with oxygen, okay, and then sulfur, okay. So this is a similarity between hydrogen and alkali metals. So alkali, okay, they are show metallic character, but hydrogen, okay, do not show metallic character, and hydrogen has high ionization enthalpy, okay, compared to alkali metal, okay. Suppose this is the nucleus, this is the electron, okay. So in hydrogen only one electron present, so there is strong force between the nucleus and the electron, okay. So ionization enthalpy means removal of the outermost electron, okay, from a gaseous, isolated gaseous atom, okay. So it becomes difficult, okay. Whereas for other, okay, elements, they have a number of shell, okay, and this shell prevent, there is shielding effect also, okay, and then it becomes easy, okay. Since the electron is far away from the nucleus, it becomes easy for the electron to be removed, okay. But for this case, high energy will be required to remove this electron, so high ionization enthalpy, okay. Hydrogen has high energy enthalpy. Next is resemblance with group 17, okay, 17 element. Let's see the electronic configuration again. 1s1. So general electronic configuration of group 17 is ns2 and p5, okay. So n can be any number, okay. This is n, okay, ns2 and p5, okay. So n can be any number, 2, 3, okay, 4. So this is the this represents the outermost shell, okay. Let's see for fluorine. 1s2, 2s2, 2p5. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p6. So the outermost electron, the configuration is s2 5, okay. This will be 5, okay. So it requires only one electron to be completely filled, okay. If it becomes 6, then it is completely filled, okay. So in the same way, hydrogen require only one electron to be completely filled. So in that way, it is similar with group 17 elements, okay. And ionization enthalpy, okay, of hydrogen is 13112 kilojoule, okay, per mole, okay. Now we see for fluorine has 1680 mole per mole, okay, kilojoule per mole. So it is similar, okay. Ionization enthalpy also is similar with the group 17 element. So hydrogen, okay, can gain one electron to become H minus. In the same way, chlorine can also gain one electron to become F minus. Okay, chlorine can also gain one electron and become Cl minus. Okay, so they gain one electron to become electronegative, or say uni-negative. Okay, uni-negative. So like halogen, okay, it also exhibit diatomic molecule, okay, exists in diatomic molecule like F2Cl2 Br2. Okay, so in this case two fluorine molecules, okay, combine to give F2. In the same way, two hydrogen molecules combine to give H2. So H2 can exist in this form, diatomic form, even halogens. Okay, this is the similarity between them. So the difference is, okay, in reactivity. So halogens are much more reactive than hydrogen. Okay, so we see the similarities and difference, okay, between the hydrogen and group 1 and group 17 element, alkali and halogens. Okay, we have seen the differences also and similarities also. So hydrogen can lose one electron, okay, to become H plus. Okay, so if it lost one electron, the size decreases. Okay, so this size becomes smaller than the parent atom. Okay, so if it lost one electron, then size decreases. Okay, that means hydrogen has very small size, and since this size is very small, okay, hydrogen does not exist freely. Okay, that means H does not exist freely. Okay, it exists in associated form. Okay, so it will be associated with molecules. Okay, molecules or atoms. Okay, and that is the reason why hydrogen exists diatomic molecule H2O, and that is the reason why hydrogen is placed first, okay, in the periodic table, okay, separately. The periodic table is not here, but if you see that periodic table, you will come across it. Next topic is isotopes of hydrogen. Isotopes of hydrogen. So we all know that isotopes, okay, are those which have same atomic number but different mass numbers. So hydrogen has 3 isotopes. The first one is protium. Protium. So the symbol is this one. Okay, so protium has no neutron. Okay, no neutron is present in protium. The second isotope is deuterium, okay, represented by this one, 2H. Okay, or sometimes as dihydrogen, or also known as heavy hydrogen. Heavy hydrogen has one neutron. The third one is tritium, 3 by 1, okay, or written as T. So it has 2 neutrons. So deuterium has 1 neutron in the nucleus, tritium has 2 neutrons in the nucleus, okay. And the third one is radioactive. The tritium is radioactive elements. Now let's go to preparation of dihydrogen. Laboratory preparation of dihydrogen, okay. Reaction of granulated zinc with dilute HCl, okay. So zinc, okay, is an active element. So reaction between zinc and HCl, okay, let's see. Zn plus HCl will give ZnCl 2 plus hydrogen. So hydrogen is liberated, okay. This will be 2. Another example can be, we can write iron, okay. Iron plus 2 HCl give FeCl2 plus H2. So the second, okay, laboratory preparation, the second one is by reaction of zinc with aqueous alkali. So zinc plus aqueous alkali, sodium hydroxide, okay. Example is, so it gives Na2 ZnO2 plus dihydrogen. So this is sodium zincate. Let's see the next one. Commercial production of dihydrogen by electrolysis of water, okay. So electrolysis of water will give hydrogen and oxygen to H2O liquid. Electrolysis will give plus oxygen, okay. So in electrolysis, what is happening is 2 electrodes will be there, okay, connected to a battery. One will be anode, okay, and one will be cathode. So at anode, oxygen is liberated, hydrogen is at cathode, hydrogen is liberated, okay, and small amount of acid or base, okay, is present, okay, here. So that electrolysis can take place, okay. So if you use water only, it will be difficult for electrolysis to take place, okay. So a small mixture of acid, either acid, okay, or base, okay, is used for electrolysis. The second one is electrolysis of brine solution, okay. So it is obtained as a byproduct, okay. NaCl plus 2H2O Cl2H2 plus Na 2NaOH. Electrolysis. So in this case, okay, the sodium chloride, okay, the reaction between sodium chloride and chlorine, okay, will give hydrogen as a byproduct, okay. Next one is reaction of steam on hydrocarbon or coke, Okay, by steam you can understand, right? Water, okay, water or steam of water, okay. And coke means carbon. So hydrocarbon example, okay, this is a general formula. H2O 1270 Kelvin nickel, and CO 2 and 1 H2. Okay, so an example is given. Okay, so the example is CH4 plus H2, methane plus water, 270 Kelvin, to give carbon monoxide and dihydrogen. Okay, so this is, okay, mixture of CO and H2O is called as water gas or synthesis gas or syn gas. Okay, since this is used, okay, to manufacture methanol and a number of hydrocarbons. So let's take another example, coke. Okay, carbon, coke plus H2O. Okay, so steam with coke, okay, steam coke to give carbon monoxide and H2. Okay, so this is known as coal gasification. Okay, since we take carbon as, okay, carbon is another form of coal. Okay, now production of this dihydrogen can be increased by reaction, okay, steaming this carbon monoxide, okay, in presence of catalyst, okay, iron chromate, FeCrO4, iron chromate, okay, in presence of iron chromate at 673 Kelvin. Okay, so in this reaction production of hydrogen is increased, O2 plus H2. So this is all for the preparation of dihydrogen.